Have you ever wondered what would actually happen if you fell into a black hole? I mean, it's a question that's just as terrifying as it is completely fascinating. Well, today, we're going to take that plunge together and find out what really lies in the abyss.
So let's just imagine it. You're an astronaut, you're on a one-way trip to the ultimate unknown. What would you actually see? What would you feel? Let me tell you, the reality is so much stranger than any science fiction you can imagine. Let's get into it.
Okay, so before we can understand what happens when you fall into a black hole, we first got to get on the same page about what a black hole even is. And for that, we have to thank Mr. Einstein and his theory of general relativity. Right. So a black hole isn't just some cosmic vacuum cleaner. It's a place where a crazy amount of mass is squished into an impossibly tiny space. So much so that it literally breaks the fabric of space-time, creating a one-way exit from our universe. Nothing gets out. Now, for this little thought experiment, let's just go ahead and assume you're wearing an absolutely indestructible suit. Okay? That way, we don't have to worry about the boring stuff like, radiation and the vacuum of space. We can focus on the truly mind-bending effects of the black hole's gravity itself. Now, here's where it gets really interesting. Believe it or not, your fate, well, it completely depends on which type of black hole you decide to fall into. We've got two main options here. First, a stellar mass black hole, basically the corpse of a giant star. Or our second choice, a supermassive black hole, like the behemoth chilling at the center of our own galaxy. Your choice here is going to determine whether you have a quick, brutal end or a seriously surreal, mind-bending journey. All right, let's take path number one. We're heading for a stellar mass black hole. And I gotta warn you, this journey is intense, it's violent, and it is brutally short. So, because this type of black hole is so small and dense, the change in gravity is enormous, even just across the length of your own body. Imagine the pull on your feet is way, way stronger than the pull on your head. You'd be stretched like a piece of spaghetti, which is exactly where the process gets its name, spaghettification. You're literally stretched into a thin stream of atoms. It's not pretty. And here's the kicker. You wouldn't even get close to the black hole's surface. Your journey is over way out, about 2,800 kilometers away. That's where the tidal forces are already lethal. So yeah, your trip is over before it even really gets going. I mean, to really put this into perspective, just try to wrap your head around this number. At only 5 kilometers from the point of no return, the tidal force across a single millimeter is 17,000 times stronger than the gravity you're feeling on Earth right now. That's a force that can tear apart matter itself. Absolutely insane. Okay, so the stellar mass black hole is clearly a death trap. Let's rewind. What about that other option? This time, we're going big. Let's head for a supermassive black hole, like Sagittarius A star, the giant at the heart of the Milky Way. Now, this is going to sound completely backwards, but because this black hole is so enormous, the curve of its gravity is spread out over a much, much larger area. This means the tidal forces at its edge are, well, they're surprisingly gentle. You could literally just float right across the point of no return without even feeling a thing. And as you get closer, the view is just spectacular. You see this perfect sphere of absolute blackness, surrounded by a glowing, superheated accretion disk. But then you notice something impossible. You see a warped image of that same disk above and below the black hole. How can you see the back of the disk from the front? Well, what you're seeing is gravitational lensing. The black hole's gravity is so powerful, it's literally bending the fabric of space-time, and light has no choice but to follow that curve. You're seeing light from the back of the disk as it's being bent around the top and bottom right into your line of sight. It's like a cosmic funhouse mirror. So as you get closer to all this gravity, it's not just light that starts to warp, it's time itself. For you, everything feels totally normal. Your watch is ticking just fine. But to someone watching you from Earth, your clock would seem to tick slower and slower and slower. You could hang out for a few minutes, maybe watch a movie, and by the time you're done, thousands, maybe millions of years could have passed for the rest of the universe. Wild, right? All right, we're here. We're at the threshold of the abyss, the point of no return. We are about to cross the event horizon. Now, it's really important to get this. The event horizon isn't a wall. It's not something you crash into. It's an invisible boundary in space-time. But once you cross it, escape is literally impossible, because to get out, you'd have to go faster than the speed of light. To your friend watching from their spaceship far away, your fall would just seem to slow down. Your image would get redder and dimmer until you seem to freeze right there on the edge, eventually just fading away into nothingness over an infinite amount of time.
But for you, the experience is completely different. The moment you cross that horizon, something incredible happens. Space and time, they swap roles. The direction towards the center of the black hole isn't a place in space anymore. It's a moment in your future. Trying to move away from it would be like trying to travel back to yesterday. It is impossible. All paths lead forward.
So once you're inside that event horizon, it doesn't matter which direction you turn, which way you fire your rockets, all paths lead to one single inevitable destination.
And that destination is the singularity, a point where all the mass of the black hole is crushed into a region of zero volume and infinite density. And here, our understanding of physics, of space, of time, it all just completely breaks down.
And as you're pulled helplessly towards this final point, those tidal forces that were so gentle when you entered, they become infinitely powerful. So your journey ends in spaghettification, just like it would have been in that smaller black hole. You're stretched, you're compressed, and ultimately you're torn apart into a stream of fundamental particles.
You know, in your final moments, you're not just at the end of your life, you're at the absolute edge of our scientific knowledge. You're at the one place in the universe where our two greatest theories of reality, general relativity and quantum mechanics, have to finally meet.
See, a black hole is so much more than just a cosmic object. It's a clue. It's a sign that our understanding of reality is still incomplete. It really makes you think, if space-time itself can just break down inside a black hole, what other fundamental rules of our universe are just sitting there waiting to be broken?